Good morning to everybody. Dear friends, today we shall start the set theory, the third session, generalized De Morgan's laws and theorem. De Morgan's laws of complements. Let A and B be two subsets of a universal set U. Then we prove that first one into bracket A union B bracket closed dash is equals to A dash intersection B dash, and A intersection B whole dash is equals to A dash union of B dash. So this one we can prove now. Let us consider the first one is A union B whole dash, that is equals to A dash union of B dash. We have considered LHS left hand side. Let X is belongs to A union B whole dash. It implies that X does not belongs to A union B because its complement is not belongs to the X. Therefore, X is belongs to A union B whole dash. Then X does not belongs to A union B. It implies that X does not belongs to A and X does not belongs to B because X does not belongs to A union B andre X is not in A and also X is not in B. So it implies that X is belongs to A dash and X is belongs to B dash because they are the complements of A and B. X is belongs to A dash and X is belongs to B dash. It implies that X is belongs to A dash intersection B dash. Thus, X is belongs to A union B whole dash. It implies that X is belongs to A dash intersection B dash. Therefore, what about LHS is there? A union B whole dash is a subset of A dash and B dash. So, next we have considered the RHS term. Let X is belongs to A dash intersection B dash. It implies that X is belongs to A dash and X is belongs to B dash. It implies that their complements X does not belongs to A and X does not belongs to B. It implies that X does not belongs to A union B. It implies that X belongs to A union B whole dash. Thus, X is belongs to A dash intersection B dash. Then X is belongs to A union B whole dash. Therefore, X is belongs to A dash intersection B dash and X is belongs to A union B whole dash means A dash intersection B dash is a subset of A union B whole dash. So the above these two equations, that is A union B whole dash is equals to A dash intersection B dash. Similarly, second one A intersection B whole dash is equals to A dash union of B dash. So this is what De Morgan's laws of complements. So any doubts are there in this uh, proof about the De Morgan's laws? So okay, next we have come to the De Morgan's theorem. So De Morgan's theorem statement is, in the examination they will ask state and prove De Morgan's theorem ಅಂತ ಕೇಳ್ಬೋದು. ಅದನ್ನ the statement is what? If the set A be an indexed family of sets, then prove that the first one is union of A whole dash is equals to intersection of A dash. ಅಲ್ಲಿ actually alpha is belongs to lambda ಅಂತ ಬರುತ್ತೆ. ಸೊ ಅಥವಾ ಲ್ಯಾಂಬ್ಡಾ ಇಸ್ ಬಿಲಾಂಗ್ಸ್ ಟು ಆಮ್ಡಾ ಅಂತ ಬರುತ್ತೆ. ಸೊ ಇಟ್ ಈಸ್ ಇನ್ಫೈನೈಟ್. ಇಟ್ ಮೀನ್ಸ್ ದ ಆರ್ಬಿಟ್ರರಿ ಆಫ್ ಯೂನಿಯನ್ ಆ್ಯಂಡ್ ಆರ್ಬಿಟ್ರರಿ ಆಫ್ ಇಂಟರ್ಸೆಕ್ಷನ್ ಅಂದಂಗೆ. ದಟ್ ಈಸ್ ವಾಟ್ ಯೂನಿಯನ್ ಆಫ್ ಎ ಹೋಲ್ ಡ್ಯಾಶ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಇಂಟರ್ಸೆಕ್ಷನ್ ಆಫ್ ಎ ಡ್ಯಾಶ್ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು, ಫಸ್ಟ್ ರಿಸಲ್ಟ್. ದೆನ್ ಸೆಕೆಂಡ್ ಒನ್ ರಿಸಲ್ಟ್ ಈಸ್ ಇಂಟರ್ಸೆಕ್ಷನ್ ಆಫ್ ಎ ಡ್ಯಾಶ್ ಬ್ರಾಕೆಟ್ ದಟ್ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ದಿ union of A dash. So we have come to the proof. Let us the given the set indexed set A be an indexed family of sets. Already in the second session you know about the definition of about what indexed family, indexed sets. So their applications we have use in the De Morgan's theorem proof. Okay. Let X be any element of union of A hold as. It implies that X is belongs to union of A hold as if and only if X does not belongs to union of A ಅನ್ನಂಗೆ. It implies that X is does not belongs to A for every lambda is belongs to lambda. Then it implies that X does not belongs to A dash for every lambda is belongs to lambda. So it implies that X is belongs to intersection of A dash. But ಏನು ಹೇಳ್ತದ ಮೇಲೆ X does not belongs to A dash. ಇದರ ಅರ್ಥ X is belongs to intersection of A dash suffix that lambda is belongs to lambda. It implies that X is belongs to union of A bracket dash. It implies that X is belongs to intersection of A dash. So therefore X is belongs to union of A dash is a subset of intersection of A dash. Call it as result number 1. And similarly intersection of A dash is equals to union of A its dash. Call it as result number 2. From result number 1 and 2 we have come to the conclusion union of A dash is equals to the intersection of A dash. So it means what applicable of De Morgan's law use. Then it is a statement, it is a proof of what? De Morgan's theorem. The second one, to prove that intersection of where or suffix lambda is belongs to lambda, A lambda bracket dash, this is equals to union of lambda is belongs to lambda, A lambda dash. Let X be an arbitrary element. Intersection of lambda is belongs to lambda, A lambda whole dash. That is X is belongs to intersection of suffix lambda is belongs to lambda, A lambda bracket completes its dash. It implies dash X does not belongs to intersection of A dash lambda bracket complete. Complement is contained in X or complementary is complement of A lambda is contained X, but intersection of A dash does not contain X ಅನ್ನಂಗೆ. It implies that X does not belongs to A for any lambda is belongs to lambda. X is belongs to A lambda dash for every lambda is belongs to lambda. So X is belongs to A lambda dash for every lambda is belongs to lambda, because so the X does not contains the element A for every lambda is belongs to lambda, but X is belongs to capital A lambda dash for every lambda is belongs to lambda. It implies that X is belongs to union of lambda is belongs to lambda, A lambda dash. Thus the X is belongs to intersection of lambda is belongs to lambda, A lambda dash. It implies that X is belongs to union of A lambda dash. Therefore intersection of A lambda bracket dash is a subset of union of A lambda dash suffix lambda is belongs to lambda. Call it as result number 3. And similarly union of A lambda dash is a subset of intersection of A lambda bracket dash. Call it as equation number 4. From 1 and 2 we have come to the conclusion intersection of A lambda whole dash is a subset of union of A lambda dash. So this is what De Morgan's theorem. So on that theorem we have come to the some very short answer questions or multiple choice questions are there. For any set A and B, the property of A union B is equals to B union A is called, is it idempotent law or distributive law or commutative law or associative law? So which property is concerned to this question? So the it means A union B is equals to B union A means it is a just you have in general the commutative property. In case of two sets, that is arbitrary union of two sets, so A union B is equals to B union A, it is a commutative law. The next question is multiple choice questions. For any set A union of null set is equals to the answer A, the answer B is null set, the answer C is universal set, answer D is none of the above. So A union of null set is what? A only. Answer is A. Then third one, for any set A, the property A intersection A is equals to A is called idempotent law or distributive law or commutative law or associative law. So for any set A, the property A intersection A is becomes A andre this is idempotent law, identity law in case of sets. The fourth question, for any set AB, A intersection B bracket close intersection C is equals to A intersection into bracket B intersection C bracket close is idempotent law, distributive law, or commutative law, or associative law. Which law is implicable or applicable? So A intersection B bracket complete intersection of C is equals to A intersection of into bracket B intersection C bracket complete is associative law. So next one is, let A and B are the two subsets of a universal set U. Then prove that A union B whole dash is becomes the following four result which is correct. The result A into bracket A union B bracket complete. The result B into bracket A intersection B bracket complete. The result C A dash union of B dash. The result D A dash intersection B dash. So A union B whole dash, it means what? This is A dash intersection of B dash. A dash intersection of B dash. So the sixth question, let A and B are the two subsets of a universal set U. A intersection B whole dash is equals to the following four results are there. The result A dash union B dash. The result B, A union B bracket complete. Result C, A dash intersection B dash. The result D, A intersection B bracket complete. So this is what our question. A intersection B whole dash is becomes to A dash union of B dash, the result. So these are the multiple choice questions. The six multiple choice questions are there. They are concerned to the De Morgan's theorem. So De Morgan's theorem is very clearly say about the property of sets, especially union and intersection of the two or three sets. So you know the definition of union and intersection, then operations, then their complements. That results is comes to the De Morgan's laws. So this is what the totally complements of the De Morgan's law and De Morgan's theorem. So if any doubts are there, please message to my WhatsApp number or call to me. Then I will give the solution. First of all, you listen the what I explain. First you observe and listen, then later you think and come to the conclusion. Are you able to the understand or not? Then next come to the multiple choice questions are there. Are you understand or not? Then you are familiar. It means first you are, many times you read, many times you listen this session. Then you are very familiar, very interesting. Then you are familiar in the sets. Okay, thank you one and all.